Hi there, and welcome back to this channel. So in this video, I'm going to take you through LU decomposition, but we consider the Doolittle method, and after we will take the Krauss method in the subsequent videos. Please, if this is the first time you have been on this channel, kindly subscribe to support, and please watch this video to the end. So as the steps for solving systems of equation, we've tackled Gaussian elimination with partial pivoting, naive, and also complete pivoting. So in this video, we're going to use LU decomposition to solve systems of equation. But before that, we need to know how to decompose the matrix into LU form using specifically Doolittle method. Okay. So generally, when you say LU decomposition, it means that you want to solve a system of system equations represented as Ax is equal to b. You know that a system of equation represent this way. A is your coefficient matrix, your x is the unknowns, and b becomes what? Your right hand side. Okay, so we want to solve this system of equation by now converting A into an LU form. LU form, where the L is a lower triangular matrix, and the U is an upper triangular matrix. Right. Yes. So once we have been able to decompose A into LU form, then how do we solve our system then? So we realize that if A is equal to LU, this equation here becomes LU multiplying X is equal to B. Is that not it? And you know that solving systems of equation, the goal is to find the values of what? X. So what do? I'm going to make X a subject, but first I'll take L out. So I'm going to take L inverse on both sides. That is the way to take L out. So that L inverse and this will give us our identity matrix I multiplying Ux is equal to L inverse B. And you know that this is the same as 1. It gives the same thing. So we are going to have Ux is equal to L inverse B. So at this point, the only thing you do is you make this part equal to a certain unknown matrix. Okay, so we know that this B that we have here is a 3 by 1 matrix, and you're multiplying that with a 3 by 3 matrix here. So we are going to have L inverse B. You will put it to, let's say, anything say Z. Okay, and once you do this, you know that this is the same as 1 over L times B is equal to C. So therefore B is equal to what? LZ, and this is one important equation we need in our LU decomposition process. So equation 1, B is equal to LZ. Okay, B is equal to LZ. So here, this is what to do. B is equal to LZ. Then the next thing is we made L inverse B to be equal to Z. So we can make the substitution back so that I get Ux is equal to what? Z. And this is simply one strong equation. So the only two equations we need is B equals LZ and US is equal to what? Z. Okay, US is equal to Z. So knowing how to use knowing how to use the LU decomposition to solve for X, then let's get straight to how we can decompose A into the LU form. And in this manner, we are using the Doolittle approach. So with the Doolittle approach, you first decompose A into unit lower triangular matrix, and strictly upper triangular matrix. So you just have to put this one in mind. A unit lower triangular matrix and strictly upper triangular matrix. So therefore, Doolittle approach says A will be equal to, the L part is represented as 1, 0, 0, we have our L21 here, we have 1 0, we have L31, L32, then you have 1. So this is what we call a unit lower triangular matrix. A unit lower triangular matrix. Then this will be multiplying and a strictly upper triangular matrix. So meaning you have U11, U12, U13. Then I'll have here to be 0, U22, U23. Then I have 0, 0, U33. So meaning that we have to convert our matrix into this form. So once you do this, then you are good to go. So the reason why it's Doolittle approach is that you realize that on the lower triangular matrix, I have units representing the principal diagonal. So all the elements on the principal diagonal become 1. They all turn 1. That's why we say unit lower triangular matrix. And here is strictly upper triangular matrix because there is no 1s here. So let's see how we can solve problems using the Doolittle approach together with the LU Decomposition method of solving systems of equation. So let's take this problem. So solve. So solve using LU decomposition with Doolittle approach. Doolittle approach. So this is what I have here. 25, 5, then 1, 64, 8, and 1, 144, 12, then 1, like this. Multiplying x1, x2, x3 is equal to, on my right side, I have 106.8, 177.2, then I have 279.2. So let's solve this problem. So in solving this problem, you need to identify the components of your system. This is the coefficient matrix represented as A. So when I write A, S is equal to B, this is the A, and this is the X, and this is the B. Okay. So our goal is to take A out and decompose it into LU. So A, which is 25, 5, 1, 64, 8, 1, 144, 12, 1. Should be decomposed into an LU form. We repeat our LU 100, L21, 10, L31, L321. Multiplying our U11, U12, U13, 0, U22, U23, 00, U33. So we have to convert our A into LU form. This is the L and this is the U. So that's the goal right now. So this is just the Doolittle mechanism. Okay. So this simple equation that we have, you just solve this and you put it to the various components here. So taking the first row, I'm going to multiply this. This is 1, please. I'll multiply this row with this column, okay, in that manner. So when I multiply this row with this column, then we will equate the resulting solution to this term, because it's this term that will give rise to this times this. Okay, so let's do that. So for that reason, I'm coming to do the multiplication. So as I said, this row times this row, I'm going to have something like 1 multiplying U11. Here will be 0. Okay, 0 times 0 times everything will be 0. Should give me 25, right? So therefore, I'll write my elements here. My U11 will be equal to 25 here. Then I'll come again. When I come, this multiplying the second column, I'll have 1 multiplying U12. This raise 0. Everything will become 0. should be equal to my 5. Therefore, this is the same as what? 5. Hence, my U12 is also 5. Then when I come the third one, I'm going to have this same thing multiplying the last row. This 0 and 0 will make this here and here 0. For that reason, I'll have 1 times U13. U13 should be equal to the 1 here. Okay, so therefore U13 is equal to 1. So I'll write my U13 is equal to 1. Now I move to the second row, multiplying each of the columns. So coming to the second row, I'm going to have my U21 and 1 multiplying this whole thing. Okay, so I have L21 multiplying U11 plus 100. So this should give me 64. Okay, 64. Therefore, I know U11 to be 25. So my L21 is simply equal to 64 over 25. And that is giving me 2.56. So you just write L21 is equal to 2.56. Okay. Then the next thing is the same row multiplying the second column. You get L21 multiplying U12 plus 1 multiplying U22, and this should give us 8. You know that L21 is 2.56. Okay, you multiply 2.56 multiplying U12 was also giving us 5, then plus U22 is equal to 8. So I need U22, so U22 is simply equal to 8 minus this expression. So we just do 8 minus 2.56. So you just do 8 minus 2.56 times 5, and that's giving me negative 4.8. So negative 4.8, right? So I'll have my U22 is equal to negative 4.8. Then I move ahead. This same row will multiply the last column. So I'll get L21 by U13, L21 by U13 plus the same 1 by U23, and this is going to give me 1 here. Okay, so once I do that, I can simply solve here. L21 is 2.56. 2.56 multiplying U13 is 1 plus 1. So here is U23. So I want to solve for U23, then I'll get my solution. So here my U23 is simply equal to 1. So here everything will be equal to 1. Everything here will be equal to 1. Okay, so this should be 1. So here I'll get U23 to be equal to 1 minus 2.56, and obviously U23 will be equal to negative 1.56, right? Then I'm done with the second. Then I come to the third row. Third row by the first column, I'm simply going to get L31 multiplying U11, right? The rest should be 0 because everything here is 0. So should give me 144. So therefore L31 will be equal to 144 over U11. So 144 over my U11 is 25. Yes, and this is giving me 144 over 25, 5.76. 5.76. So my L31 is equal to 5.76. Okay, so let's see L31. So at this point, I'm not done. I'm left with this one times the second column. So I'll still have, let me cut here. I'll still have L31 here by U12 plus L32 multiplying U22, and this should give me 12, right? Yes. So L31, do I know? Yes, 5.76 multiplying my U12. U12 here is giving us 5. It's giving us 5. So I'll have plus L32. Do I know L32? Yes, you haven't found it yet. So L32 multiplying what? U22. And U22 is giving us negative 4.8. And this is equal to, I'm multiplying this, so it's equal to 12. Yes. So what is 5.76 times 5? That is 28.8 plus. So here I'll just maintain it. L32 negative 4.8 equals 12. So here I'll just subtract it. Okay. So I'm going to have 12 minus 28.8. That will be giving negative 16.8. So I'll have L32 multiplying negative 4.8 is equal to negative 16.8. So my L32 simply equals negative 16.8 over negative 4.8. So what am I getting? I'm getting 3.5. So L32 is equal to 3.5. Okay. Then finally, this same row multiplying by the last column. So let me clean some parts here. So at this point, this time the last column, I'll have L31 multiplying U13 plus my L32 here multiplying U23 plus 1 multiplying U33 is equal to 1 here. Okay, so L31 is giving us 5.76, L13 is giving us 1, okay, plus L32 is giving us 3.5 multiplying U23 is negative 1.56. Then finally plus U33 is equal to 1. So here is 5.76 plus 0.5 multiplying negative 1.56. That's 0.3. So here is 0.3 plus U33 is equal to 1. Therefore, U33 is equal to 1 minus 0.3 to 0.7. Okay. So we simply write U33 is equal to 0.7. And that gives us the entries of the various components here. So I can move ahead to write my decomposed form LNU by simply substituting what I have here. So I'll just take everything off here. Then I'll write my matrix here so that you see the LU decomposed form here. Okay, so now let's move straight. My L is simply equal to 1, 0, 0. L21, what's L21? L21 is here, it's giving us 2.56. L31 is giving us 5.76. L32 is giving us 0.7. 1, then here is 0, then 1. I'm done with my L. So my U comes with U11 to 25, 5, 1. That is this entries. Then 0, my U22 is negative 4.8. Then my U23 is negative 1.56. Then 0, 0. I'm having 0.7, right? 0.7. So this gives us our LU decomposed form, and we're almost done. So once you get the LU decomposed form, we can go ahead and solve. So let me reproduce my LU form here. So now my A is equal to 1, 0, 0. So I'll have my 2.5610, 2.5610, 5.76, 0.7, then 1, right? Multiplying 25. Yes, so multiplying 25, 5, then 1, 0, negative 4.8, negative 1.56, then 0, 0, 0.7. Okay, so once I get this, I move straight to finding the x because I know the b, right? So from the problem, the b is 106.8, 177.2, then 279.2. So I'll just write my b, which is equal to 106.8, 177.2, 279.2, right? Yes. So now I'm to find the values of x and remember the equations I gave from the beginning. I gave some two important equations here. Yes, I said that we have the LZ equals B, then US is equal to Z. So get that in mind. Okay. So LZ is equal to B. What's my L? This is my L. I just carry my L here. So 100, 2.56, 10, 5.76, 0.71. Sorry, this is not 0.7. My L32 is 3.5 instead. So here is 3.5. Sorry. So I get 3.5 here. Then I will just change this side to this 3.5. So I'll have a change here as well. So 3.5 here. So L, then the Z has entries Z1, Z2, Z3. Okay. It's equal to my B. What's the B? 106.8, 177.2, 279.2, right? Yes. So once I get this, then I'm going to solve the equation and equate it. So for the first equation, 1, 0, 0, multiplying this column. So 1 by this, I get Z1 is equal to, the rest will be 0, is equal to what? 106.8. Then that's all. Then the second equation, I'll have 2.56 times Z1, 2.56 multiplying Z1 plus 1 by Z2, 1 by Z2, okay? And this will give us 177.2. So this is what we call forward substitution, okay? So here, I know my Z1 to 106.8, okay? So 2.56, 106.8 plus Z2 is equal to 177.2, right? So 106.8 times 2.56 is going to give me 273.408 plus Z2 is equal to 177.2. So my Z2 is equal to 177.2 minus 273.408. So I'm going to get Z2 to be negative 96.208. Then finally, what is Z3? This whole thing multiplying this, I get 5.76 Z1 plus 3.5 Z2 plus Z3 is equal to 279.2. Okay. So at this point, I know my Z1, so 5.76 dot Z1, which is 106.8 plus 0.5 multiplying Z2. Z2 is giving us negative 96.208, then plus Z3, which I haven't found, is equal to 279.2. So I'll just multiply this 5.76 by 106.8. Then we are getting 615.168. Then what is this? Negative 96.208 times 0.5. That's giving me minus 336.728 plus Z3 is equal to 279.2. Okay, so at this point, let me do this simple subtraction here. I get 615.168 minus 336.728, right? And that is giving me 278.44 plus Z3 is equal to 279.2. So my Z3 is simply equal to 279.2 minus 278.44, right? And that is 0.76. 0.76. So when I get this done, I simply write my Z1, Z2, C1, C2, C3 is equal to 106.8. My Z2 is equal to negative 96.208. Then my Z3 is equal to 0.76, right? Yeah. So once I get this, the last equation was ux is equal to z, right? So this way we are going to get the actual s. So expanding this, I'm going to have something like, I'm going to have my u part of the equation multiplying what x, right? So what's the u part of the equation? So from here, I'm going to have 25, 5, 1. So 25, 5, 1. Then I'll have 0, negative 4.8, negative 1.56, negative 1.56. Then the final part will be 0, 0, 0.7. Right, yes. So once I write this, the x part becomes my x1, x2, x3. So this is the actual s you want to find. Should be equal to the z that we just found. 106.8, negative 96.208, then 0.76, right? So once I get this done, I just do my backward substitution. Okay, so here for the last part, this what when you multiply this whole row by this, everything will be 0. So I'll be left with 0.7 by x3 should give me 0.76. Okay, so what is my x3? So my x3 is simply equal to 0.76 over 0.7, and that is approaching 1. So I'm getting 1.0857. Then the second part, this part, I'll multiply this whole part. This is backward substitution, so the x1 will be 0. So I'll have negative 4.8 x2 minus 1.56 x3. This should give us negative 96.208, right? So I have my x2. I don't have it. Okay, I don't have it. X2 minus 1.56. My x3 is 1.0857. equals negative 96.208. So this expression will give me negative 4.8 x2. What is this? Negative 1.56 times 1.0857. So minus 1.6937. Okay, is equal to negative 96.208. So I can solve this to also get my x2. So my x2 is simply equal to negative 96.208 plus 1.6937, right? And that is giving me negative 94.5143 all over the expression negative 4.8, right? Yeah. And what am I getting? 19 point, I'm getting 19.69. Then let's write our final answer. This time the whole thing. Okay, so the final answer will be, the final step, 25x1 plus 5x2 plus x3 is equal to what? 106.8. So 25x1, I don't know x1, but I have x2 to be what? 19.69. Then my x3, which is plus 1.0857, should be 106.8. So I just multiply this and add this. So 5 times 19.69 plus 1.0857 So I'm going to get 25x1 plus 99.5357, right, is equal to 106.8. So I'll have 25x1 to be equal to, I'm subtracting 106.8, doing this subtraction, minus 99.5357, and this is 7.2643. So x1 is simply equal to 7.2643 all over 25. All right, and what am I getting? I'm getting 0.29. Okay, 0.29. So therefore x1 is equal to, from 1.0857, x2 is equal to 19.69, then x3 is equal to 0.29. So this is the end of our video. Thank you for watching, and please don't forget to subscribe, like, then you also share.